Hello everyone, we are BioInspira. We are taking gas sensing to the next level. In 2010 September night, early evening, when people are having dinner with family, a 30-inch diameter natural gas pipeline exploded into flames in the residential neighborhood of San Bruno, a suburb of San Francisco. It's only 2 miles west of San Francisco Airport. Unfortunately, 8 people died in the explosion. 58 people were injured, and 108 homes were destroyed or damaged. Every year in the United States, there are more than 200 pipeline-related incidents similar to this happened. Besides, simply by leaking gas itself, we are losing $5 billion worth of gas annually in the States. And this is because current gas detection solutions fall short in terms of cost, accuracy, and connectivity. Utility companies literally have to send people into the field, using handheld detectors to walk through their pipeline, or using mobile surveyors to drive through their territory for leak inspection. And it takes them so long, a complete scan of their territory can take 3 years or more. This is ridiculously inefficient. And the problems of current sensing technologies are that they are either too bulky, too expensive, require too much power, or they are cheap, small, but with low sensitivity. All of these cannot enable real-time and remote monitoring for the industry. We need technology that combines the advantage of both systems. My name is Ray, founder and CEO of BioInspira. We have a revolutionary technology that does just that. Our chemical sensors are made from M13 bacteriophage. We engineer specific design receptors into phages. Selecting phages to sense specific chemicals is simple. By using phage display, a well-developed high-throughput natural selection process, we can develop new types of sensors for almost all chemicals in less than 3 months. And then we grow the engineered phage in E. coli to make countless identical copies and make them into arrays of colored thin films. These colored thin films will change colors depending on types of gases and concentrations. We then digitally analyze these films to color sensors and wirelessly transmit all this information back to our central cloud server for further analysis, where we do event notifications and predictive maintenance for our customers. This is a patent-pending technology we invented at Lawrence Berkeley National Lab, and BioInspira is the global exclusive licensee to it. With our technology, we surpass current sensing limitations to provide wireless, small, low-cost, low-power, and accurate sensors. This makes it possible to have real-time and large area monitoring that can identify and fix problems much before they develop into catastrophic events. In my hand, I hold our first prototype that was done at IndieBio. This sensor module can detect up to 5 different gases at once to give a unique pattern for the air composition. And the white box is our whole sensor system that includes batteries and wireless communication module. By the end of this year, we will shrink the size of the whole system down to only 2 cubic inch, which can fit into my hand. Here you can see our sensor array gives different patterns when exposing to different chemicals. We can detect methane, ethane, and mercaptan, the odor when they put into natural gas, at 100 parts per million and 1 parts per million respectively. And our sensor also shows very stable and fast responses over repetitive exposure cycles. We've conducted more than 100 interviews with potential customers and industry experts, so we understand very well what they need and their specifications. We compare pricing, sensitivity range, power requirement along with other technologies and customers' needs. We are at the sweet spot and the only one that can implement detection grid for the industry. We are first targeting the whole vertical of natural gas industry, which is a $4.5 billion market. By including the global markets of gas sensors and analyzers, we are looking at a total addressable market of $18.8 billion with a fast growth rate, 11% annual growth rate over the next 4 years. Our business model includes one-time sensor sales and recurring service fee. This ensures easy adoption and continuous revenue stream. Sensor networks are not just a vision. This is happening right now. And I'm so excited to share with you that we've landed a pay pilot from consortium of utility companies that includes 2 largest utilities in the States and 1 largest utility in the East Coast. Besides, we already signed 4 letters of intent that come with more than 600 units per order and potentially $500,000 contracts. On the manufacturing side, we partner with the major ODM in Asia to help us deliver our products to customers. In the past 4 months, we've been granted more than accumulated $1.8 million non-dilutive government funding from National Science Foundation and Taiwan Ministry of Science and Technology. I have a strong team to support me. Benson and I have been working together on this technology for more than 3 years. Jimmy has more than 20 years experience in hardware system level design, and Dr. Dunn has been working in biotechnology industry for the past 15 years. Our lead advisor is Ram Shenoy, who is the former CTO of ConocoPhillips and former advisory board to the US Secretary of Energy. We also have former CTO of HP and former VP of Oracle on board as our business strategy advisors. With the ability to develop new sensors more quickly and more economically than current sensing technologies, we can go into new markets very fast, such as refineries, commercial buildings, coal mining industry, and airports. They are all billion-dollar size markets, and we already have plans to penetrate all these markets in the next 5 years. We've successfully raised $1.3 million, and we are now raising a $3 million round to expedite our business and product development. Come join our journey and let us build a safe and smart world together. Thank you very much.